Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on the 24th of June, 2025, T 3 hours, 53 minutes, and 36 seconds, .0000. This paper, published just 2 days ago, introduces a model that hits 47% accuracy on a tough software engineering benchmark, a new record for models of its size. The paper is titled Skywork-SWE, Unveiling Data Scaling Laws for Software Engineering and LLMs, and it makes a compelling case that high-quality data is the real key to progress here. On Hugging Face, you can find the 32 billion parameter Skywork-SWE model with downloadable weights and usage examples to help you get started on your software engineering tasks. And these charts really drive that point home. The top plot illustrates a clear data scaling law. As the number of training examples or trajectories increases, the model's performance on the SWE benchmark climbs steadily. This performance is measured by pass at 1 accuracy, which means the model gets only one shot to solve the problem. Then, the bottom chart shows that by using a method called test time scaling, or TTS, which basically lets the model try a few times, its performance jumps to 47%, beating other models. So to really understand why this new data is so effective, this table provides a great comparison. It looks at key quality metrics for software engineering datasets. You have the executable environment, which means each problem comes with a ready-to-run setup. Verified unit tests, which are tests confirmed to work correctly. And a code execution suite, which automates the whole testing process. Looking at the table, you can see most other datasets are missing at least one of these. But the new Skywork-SWE dataset has all three, plus great scale and diversity. So how did they actually build this dataset? This figure lays out their 3-stage automated pipeline. First, they collect data by scraping GitHub for suggested code changes. Then, in the crucial second stage, they validate everything. They use a tool called Docker to create a consistent, self-contained environment for each problem and run tests to ensure the bug is real and the fix works. Finally, they use advanced models to generate successful solutions, recording each step. This recorded solution, or trajectory, becomes the high-quality training data for their new model. And this table really puts that new data to the test, showing the final performance results. It compares their new Skywork-SWE model against a whole range of others, both proprietary models like GPT-4 and Claude, and a long list of open-source models. What's striking is that their 32 billion parameter model, listed at the bottom, hits a 38% resolve rate on its own. This result establishes a new state-of-the-art for models of this size, and with test time scaling, it reaches 47%, which really closes the gap with top proprietary systems. So to wrap things up, this work makes a powerful argument. It's not just about bigger models, but about smarter, higher quality, execution-grounded data. The authors showed that data scaling laws, where more data means better performance, hold true for complex software engineering. Their automated pipeline for generating thousands of validated, step-by-step solutions, or agent trajectories, provides a clear path forward. That's our look at Skywork-SWE. Thanks for joining the AI Research Roundup. I'm Alex, and we'll see you next time.